Awesome. Yeah, as already said, I'm Michael. I'm a senior solution architect with Rangle. You can find me on the socials. I will share the slide on the meetup channel as well. So later on, if you want to go through any of the slides, or if you can't read anything, like in the back, there might be a chance that some of the text is a little bit small. You can just look it up on the meetups.com page later. Okay, today I'm going to talk about Team APIs, how to architect organizations using Conway's law. Just a quick show of hands, who of you is familiar with Conway's law? That's about a third, so actually probably a bit less than a third. So Conway's law states that any organization that designs a system will produce a design whose structure is a copy of the organization's communication structure. So Conway proposed this in 1968, so a good while ago. And since then, scientific research has shown this and proven this to be actually true. So there have been a couple of scientific reports going into this and like figuring out, does the structure of an organization actually end up with a software solution that is roughly mirroring those communication paths? And a lot of times, this might be okay. So like in this case, you can see that the payments team communicates with the API teams, which communicates with the UI team and the accounts team, which results in a pretty standard and pretty sensible solution. But once you're going to something like this, your solution is probably going to be a little bit crazy, and it's sort of like the crazy in, crazy out type of problem. So Conway's law leads, if we're sort of like assuming that Conway's law is correct, which it has proven to be, that anybody who makes decision about the shape and placement of engineering teams is strongly influencing the software systems architecture. So we can use this to our advantage and just think about like how do we want the architecture of a particular solution to be, and then go back when planning out team structures, team communications, and basically design the software and the team interactions together, rather than just doing it ad hoc or doing one before the other. So since they are intrinsically linked with each other, we will get a lot of benefits from thinking about this. But let's go a step back and think about what makes up those teams actually, like what makes the high-performing teams. A good team is sort of, like a cake. It has quite a lot of like different ingredients, and a lot of those are standardized and will apply to all teams. Having the right skills is super important. Having the right diversity within the team is super important. Restricting the cognitive load and restricting the amount that teams need to keep in their head. Having a lot of different things and need to worry about a lot of different things makes it a whole lot harder to be clear or like fix the problems that you're having at hand and trying to build the best solution. So having clear boundaries, having a clear purpose, having a clear, clear expectation on what the team is supposed to do, and a clear ownership really makes it a lot easier for teams to succeed in their mission and to be autonomous in solving the problem that they have. And this also like leads to high trust teams that are trusting each other. Also, another important part is the 2 pizzas. So Amazon came up with that model that like a team should not be bigger to be fed by 2 pizzas. It didn't say how large those pizzas are, but I would assume, based on Dunbar's number, the upper bound would be 15 or 16 people usually. That should be the maximum upper bound of a team, but ideally a bit smaller, just to clarify the communication, to have really simple and straightforward communication paths. Coming to the topic of this talk, the Team APIs. Team APIs are basically meant to be the interface to a team, similar like the APIs that we all know from IPAs and APIs. APIs and IPAs. Depends on like what you're coming here for. You can switch it the other way around. It's really important to have a standardized interface and to make it clear what your teams are supposed to do, how to communicate with them, what their expectation is to requests coming from other teams. Thinking about a regular API, you have your HTTP verbs, you have your REST definitions where you know you have specific endpoints, specific resources that you can interact with, and applying that to teams, you can sort of like define the outside interface into a team and making it a little bit encapsulated that not everybody communicating with that team needs to know all of the intricate details of the purpose, all of the domain and context that is encapsulated within that team, but just makes it very easy to communicate with each other. So team APIs, as a definition, can include things like the library servers, endpoints, clients, and the UIs that the team is managing. So if you're a payment gateway company or team, for instance, like knowing what is the server that you're connecting to or that other teams can connect to, what type of versioning are you following? If you're publishing a library or so, it's really important to follow very clear versioning guidelines just for consuming teams to be aware of having this contract with you that they know if there is a breaking change, it will be a major release. It will not just creep in within a feature release. So like understanding how people are consuming your libraries or design system, component libraries, all types of software that is being used within other systems that is not just a server. But like even for a server, versioning is important as well. A lot of types in APIs, you see the like V1, V2 type of versioning scheme, and being aware of being backwards compatible ideally, and in the worst case, like be very clear about like what you're making or how your consumers are going to consume your data. Another important part of the team APIs is the documentations or having some types of playground. So like if you're dealing with a design system, for instance, or a component library, it's super useful for your consumers to actually interact and see all of those components, being able to play around, having a storybook or a zero height or a supernova type of setup can be super useful in just scaling the way that other teams can consume your data. Since if you need to personally run everybody through the code base for them to consume your library, it doesn't scale very well. Like after a short time, half of your team is just busy showing other teams how they're supposed to use your library. Another artifact that is often quite useful is also having a roadmap. So having other teams being aware of where you're going, what your next plans are, and how you're planning to transform your product or your internal product in a sense is super powerful in just making sure that it aligns with their roadmaps, it aligns with their plans. And one of the other core parts is the communication preferences. Where can you reach your team? If you have a problem, how do you contact them? Do you have a on-call service where you can look up whoever is on call currently and just call them directly? You have a pager duty type of setup, or do you just use a Slack channel? What is sort of like the patterns of your Slack channels? Like being explicit and ideally company-wide, have very easy to guess names of what your team's channel is going to be. So like if it's the database team, having database somewhere in the name is probably going to be a good idea, just for discoverability. Other teams might require certain other interaction patterns, like for Jira ticket, having a Jira ticket if you have a new feature request or if you find a bug. In other cases, it might be a GitHub issue. Like there are so many ways that teams can interact with you, and being explicit about this and having a central point where other teams can find that data is super powerful in just clarifying and simplifying the overall interactions. Another item that can be pretty useful are principles and practices. So if your team is accepting pull requests from other teams, for instance, you might want to share your standard coding practices or like your test coverage baseline, that if you're getting a pull request, you need that 80% test coverage, for instance, or that visual diff testing or the end-to-end automation that needs to be done, rather than having to go back and forth, and just making it easier for the people that contribute to your team, as well as for your team as well, to not have to repeat the same content over and over again. And the last item that might be useful in a team API is something like a SLA, to just know, okay, we're we're having this payment gateway and we're guaranteeing 5 nines of uptime, for instance. Just to have that expectations that other teams, if they know, okay, we want to use this internal library from a platform team or something, these are the SLAs that they are guaranteeing us, and or a certain like time to fix a bug or something. This list can just go on, and depending on your organization and depending on the problem domain or the type of software that is being worked on, these vary and may or not be relevant. But just thinking about it and thinking about like, if I encapsulate my team and want to make it easy for other teams to interface with it, what information do they need, and how can I basically have a very effective communication for them. To summarize this, for an effective team-first ownership of software, teams need to continuously define, advertise, test and evolve the team API to ensure that it's fit for the purpose of the consumer of that API, other teams. So to just like overall make that communication as smooth and as clear as possible and as easy for other teams. This heavily relies on team topologies, which is a book that was, I think, released 3 years ago, roughly. One of the other parts which makes it much easier as well to think about team APIs is to think about the team topologies and like the fundamental team types. So based on research, teams can pretty well in most cases be slotted and bucketed into 4 different types of teams. There is the stream-aligned team, which is a team that makes up in most organizations around 60 or 70% of the teams overall, which are the value stream-aligned teams that are delivering end-user features, that are delivering the business value, that are basically like doing the end-to-end work of making money for the company directly. And the other type of team is the enabling team, which is more a type of consultant or kind of Mary Poppins team that pops in and out of other teams and basically helps to mentor and upskill them. So thinking about the company decides to adopt GraphQL, and the enablement team then goes from team to team and helps them with adopting to GraphQL, to implement it within their code base, to teach them best practices for actually like running and maintaining their GraphQL setup, as well as perhaps at first how to model their data, or helping them with a migration over to modeling from a REST API to a GraphQL API, for instance, or RPC, or any other type of migration that you might have, where you do have a sort of center of excellence type of, or like a community of practice that might come up with a move that the entire company wants to follow. The third team type is the complicated subsystem teams, which is a type of team that basically encapsulates a very complicated domain-specific problem that you won't find in all of the stream-aligned teams. So thinking about AI, even though AI got a whole lot easier right now. So like AI last year, perhaps, where you really need a specialist for training your model. You probably still want to have a specialist nowadays as well. But having a very, where you need very specific knowledge, like certain text records or mathematical models to predict certain stock market events or something, which you want to encapsulate into like one single subsystem, whether it's a service, whether it's just a module or something. It doesn't really matter, but it's basically an encapsulated team that contains that specialized knowledge that can't be just shared between cross-functional stream-aligned teams. And the last team on the list is the platform team. The platform team is a team that enables other teams or internally builds products in a way. So you can think about, for instance, setting up servers or something, or automating a lot of the orchestrations, etc. of those, having those encapsulated as a server that you just have a standardized image, a standardized setup, would be one offering of a platform team. Another one could be to have a logging library, or so to just have a standardized way the company is doing logging and sharing that across different teams and having it maintained by one team as an internal product. So like you have a software as a service company for specific other solutions, you can follow the same model in-house as well and basically create your internal product with having very stream-aligned or company value-aligned offerings that either customize or fully build a specific solution that is useful to many internal teams. If it's only useful for one team, you probably don't want to have a platform team. But in case that there are some like cross-team concerns, this might be a good solution. And then going to those teams, they're also communicating with each other. Team topology proposes 3 types of interaction mode, one being collaboration. So this can be 2 stream-aligned teams collaborating with each other on an API between each other or for a specific way of best practices of how to do something. It could be a platform team working with a stream-aligned team to test and validate and quickly evolve their offering of a specific hosted service or a specific automation script or something. The next one is X as a service, which is sort of the default mode of the platform team, but should ideally be the default mode for a lot of teams, since it's the most scalable one. So you won't have as many issues with like having to support other teams if you do it as a service. So it's self-serve, it's automated, it has a nice documentation, it is nicely done, or it says what it does and what it doesn't do. So the X as a service is like the most scalable interaction mode of those 3. And the last one is the facilitation, which is the most common way of the enabling team, basically mentoring one of the other teams and helping them for a certain amount of time to teach them to fish effectively. This is an example of what like a team API registry in a way could look like. This is just a fragment, so you might have more columns, you will probably have more content within here, and you'll probably have links and additional information, but basically depending on the team type, you might or might not have certain parts. So like an enabling team, for instance, would not really have code artifacts because they're busy helping teams with their code artifacts or with their code and their setup and their versioning, so they wouldn't really have those. But you would want to like be very clear about like the communication that you have. Like your stream-aligned card team has the Slack channel feature dash card that you follow the same pattern that every team, for instance, does with feature dash if you're in a stream-aligned feature team, for instance. And just sort of like making it clear across the different types of teams how what you're providing and what other teams should expect from your software. Which leads us to the last part, the team modeling, sort of like bringing the team APIs and how Conway's law can actually help you to architect your organization. Conway once said, if there is a better design that is not available to, is there a better design that is not available to us because of our organization? Sorry, I'm just quickly gonna get some water. Just adding a little bit suspense. Yeah, so we do have the 5 fundamental team topologies that we talked about before. Those are getting modeled as the stream-aligned team is basically this yellow bar. The enabling team is a red bar, or like a vertical bar, while the complicated subsystem team is a purple square, and the platform team is a thick turquoise bar. So you can use those to then model how the teams are interacting with each other over time. And thinking about this is probably nothing that you would do within your team, but like more for like planning if you do manage teams, or if you're involved in the process of planning out a larger endeavor with multiple teams. This is a very nice way of just thinking about like which teams are interacting with each other and how do they communicate with each other. So the x-axis is basically the flow of change, the time axis. So in this case, you would read it as the complicated subsystem team is basically feeding into 3 different streamlined teams, which then get some assistance from one enabling team, and all of that is based on the foundation of the platform team. If you also add the interactions, you can also sort of like mark those as you have the complicated subsystem as a service. There is a certain facilitation happening here for 2 of the streamlined systems, and the 3rd streamlined system is spending some time collaborating with the platform team. So this is a very elegant, it has very simple ingredients, but it's very powerful in modeling or visualizing that type of interactions and communicating them with other teams or with other stakeholders potentially of what the plan is and how you envision a specific like project to go. And this is always also meant to be only a snapshot in time. So like those things are changing. So if you're collaborating, you might do it for a certain amount of time, but then you will stop and you will move potentially to an X as a service type of interaction. So this is a very interesting way of doing that. And this was it. Thank you very much. Are there any questions? Does anybody have any questions?
Hi, thank you so much for your talk. I think the API concept is really interesting to think about teams. One thing I often think about with APIs is, especially you mentioned with teams, they may have multiple touch points, is when I as a team am interacting with another team, this kind of like lends itself, to me at least, I'm thinking about like how we kind of abstract the APIs we use. So if I'm building software that uses another API, I may build some abstraction around the API, or I might have rules on how I want my software to interact with that API. I'd love to hear more about your thoughts on like how that aspect of the kind of API facilitation works. Like, would you suggest that teams, for instance, have internal documentation specifying how they choose to interact with other teams, or build something around that? I'd be curious to hear your thoughts.
Yeah, that's a really good talk. So I think something like an internal working agreement or so might be a good solution for sort of like codifying that. And I think some of that might even be something that we want to externalize or want to have part of the Team API to actually say, okay, our standard way of externally working with other teams, like we always require this authorization or like bearer token HTTP header, or like what the sort of like technical side of the communication looks like. So it can encompass, or it should encompass both the squishy parts and the technical parts in a way of like how you want to have that communication happen. Since if you have the technology part in it, it's much more scalable and easier for other teams to just read it and understand it based on what's available there. Did that answer your question adequately?
My question is, what's the ideal team size for effectively following this API team requirement? So for example, Agile says 7 plus minus 2. So what's the ideal, is it same here or something different?
Yeah, so like it does follow the sort of 2 pizza rule model with like max 16, but I would say probably something around 8 or so is probably like a more realistic. It depends a little bit on like what domain you're working on. Is it often smaller is better, and just streamlining that communication. If you don't need 8 people to a team just to like fit a specific number, just I suppose as little people as you can get away with, and that sort of like still have that cross-functional profile of whatever problem you're trying to solve.
Thank you.
Thank you for the talk. I was just wondering, your model is, I really like the model and the different conceptualizations of it, but where would you say would be common pitfalls or points where it starts to break down? One that I was thinking of were hierarchies. So I know in a lot of companies like to say that they're all hierarchical and all that, but there are a lot of internalized hierarchies, of course, and so just wondering what your thoughts on that would be.
Yeah, like I think it lends itself very well to like model the sort of operational side of like teams that are on the ground and actually doing the work. I'm not sure how or if it's possible to also model sort of like teams of directors or something, or sort of like the more managerial part. I suppose you could have them in enabling. It doesn't. Yeah, like I think it's sort of like more for actually like delivering the value and sort of like building out the software. So I think it doesn't lend itself very well to like go up the hierarchy. So I agree on that point.
Hi, thank you for the topic. I'd like to ask, in that diagram you showed, there were several teams working together. Have you had any experience like with orchestrating planning for several of teams? Is it like common backlog, or maybe it's some like large scrum or whatsoever? What can you say here?
So in this case, it would be more each one of the teams is handling their own backlog. Of course, with like communicating, if there are some cross concerns, so like wherever you have the collaboration type of interaction, just trying not to poke over any of the wires, where you have the collaboration type of communication, you might want to like, oops, did I touch any? Hello? Yeah. There might be some more alignment required between the teams, but other than that, the stream-aligned teams, basically, each one of them is handling their own backlog. Same for the platform team, same for the enabling team. The enabling team, I'm not even sure if they would really have a backlog because they're more coaching specific teams. But the complicated subsystem team as well would have their own backlog. And there might be some interaction and just like based on feature requests or something that you want to prioritize something because another team is depending on it. But other than that, each one of the teams is sort of like the nuclear unit of delivering value in that case. So it's more like a team of teams, or like a cross-team type of model.
Hi, so I have a question about the X as a service collaboration model. Do you have any strategies for coping with an internal service becoming too successful and then getting too many demands or too many bug reports or things like that, aside from just throwing more people at it?
Yeah, like I guess you can only like throw people at it to a certain amount. After a certain amount, it takes more time to actually orchestrate all of the people than getting things done. I would say one thing might be to do some type of like litmus test if it's possible to perhaps break that into two teams and have teams focusing on specific aspects of that problem. Might be one solution to it. Another one might be to just do really hard prioritization, which one of the bugs are the most relevant. But it's always hard to tell a team like, sorry, the bug is not important to us. So like finding a way potentially in this direction, it's a tough problem to deal with, but I would say breaking it into multiple teams and having it, if the problem lends itself to it. Sometimes you can't really break things into smaller units, but that would be probably what I would recommend.
All right,
There we go. We got time for a few more questions, so we're on right here.
Thank you for the talk. You mentioned that people in charge of engineering teams usually influence the design of the system quite a lot, and people in teams change. What are the practices that maybe in some type of systems, even fail-safes, that we could take to make sure that there are consistencies there in overall design of the system?
Yeah, That's a very good question. I guess one of them being that like if the teams are aligned or the domain is broken into the correct problems in like shaping the macro architecture of the system, or sort of like giving you at least a bit of success to like reach that desired macro architecture. You have like a little bit of a fail-safe first, but like then in the end it's about within the teams to have the correct skill composition. That like you do have a team that has a certain amount of redundancy in like having like if you're really relying on one like super senior superstar developer, to have a couple of people in there as well that are just like about to reach that. So like if that person would leave, you're not ending up with a incapacitated team. Might be one solution. Have to think about that a little bit more. Yeah, that's the only thing that I can think about now, but I'll think about it and might get back to you later if I can think of anything.
Any other questions? Oh, yeah, perfect. Let me bring the microphone over. Yeah. Whoa.
This gives you a pretty good
Cool.
exercise.
I know, get my exercise.
Yeah, thank you. So, can't see you, but yes, somebody asked you about Agile, but I'm going to go my question now. Do you have any examples of when you scaled up and scaled out in your framework? So case in point, some of my clients are product shops. Some of my clients are program shops. Some of my clients have PMO, some of them don't have programs. I mean, I get it. Maybe that diagram, that language, modal language, whatever that thing is, maybe applicable to a company of 50 people, 100 people, 200, 300 people. But as companies merge, as they go through M&A, or in terms of enterprise infrastructure, we'll talk about 5,000, 10,000 people. How do you scale it up? How do you scale it up?
Yeah. It's an interesting problem. I'm not sure, like to some extent you can scale it up, but like with 10,000 people, you're just ending up with a pretty messy diagram, likely. I would potentially like break it down by division or so, or like if within the company there are some specific boundaries of specific systems or so that can be relatively encapsulated. That might be one way of dealing with it. Other than that, perhaps have like a macro view of it, of like, yeah, but like you won't really have like a division of the company being like a facilitating or a collaboration. So it might not scale as well for that size. Plus you would have to have all of the teams sort of like defining all of the different interfaces. So it's the question whether it's something that, I will have to think about that a little bit more. I can't give you a direct answer, but certainly an interesting problem. But I feel like having some like breakpoints within the organization where you say like, okay, we're sort of like defining the team API there within this division or in this sub-brand of the merged company or so. But yeah, I'm not sure.
Hi, I'm just wondering, do you mean like how you control something like that? Like, is that part of the question?
I think, if I understood it correctly, I think it was a question for you. So from my understanding, it was about like how would you model that, or how would you visualize that at that scale? Did I
I don't know any other word to describe it, but I would describe it as how would you control such a large amount of people? I think that's what he meant.
Okay, just or like having this macro architecture of like the okay. I see it as a no. That was not the question.
Awesome. We have time for probably one or two more questions, if there are any out there. Any final thoughts, questions, comments? Awesome. All right. Well, let's give a big round of applause for Michael. Thank you so much, Michael, for that awesome talk.
I forgot, there's also an appendix. There is a Team APIs template as well that the Team Topologies team has created. And there are some modeling templates for pretty much all diagramming tools as well. And this is the book, Team Topologies as well, if somebody's interested. I will share the slides on the meetup.com site, and also Rangle is hiring developers. If anybody's interested, come talk to me or talk to Jason over here if you're interested. So yeah, thanks for listening.
Thanks, Michael. Awesome.